Hello everyone, myself Alkadip Mandal and I am back again with another screencast video. In this video, I will be screencasting my performance over the Leetcode bi-weekly contest 72. The contest duration is of 1 hour and 30 minutes and there is a penalty time of 5 minutes for each wrong submission. So we will try not to make too much of wrong submissions. So let's see how it goes. The problems will appear here in about 45 seconds and I hope my OBS is recording fine, and best of luck to all of you. Let's see how it goes. About 20 seconds remaining for the contest to start. 16 seconds, 15, 14, 13. Let's start and see how it goes. Best of luck. Screen is lagging a little bit. I think it is because of OBS only. Lagging a lot. So, okay. 1, 2, 3, 4. Count equal and divisible. Okay. Given a 0 and a shared nums of length and integer care, it can the number of pairs ij, constant is pretty small, for I less than j such that nums equals to num j and I into j is divisible by k. Okay. Cool. So it's not a pretty easy problem. 0 for in I equal to 0 I less than plus plus j equals to I plus 1 j less than n j plus plus if a of I equals to a of j and then I plus 1 into j plus 1 percentage k equal to 0. Answer plus plus. Answer. I think that's it. Pretty easy problem. Compilation error. Okay. N equals to a dot size. I am recently using JavaScript a little bit, so it is happening like this here. 3 answer and 4 is the answer. Nums 0, 2, 3. F I equals to j and then I plus 1 into. Okay. So this is only I into j and I into j. I into j. So 4 is the answer. This is the right answer right now. So let's submit right now. Find 3 consecutive integers that sum to a given number. Given an integer num, return 3 consecutive integers as a sorted data that sum to num. If num cannot be expressed, some 3 consecutive, return an empty array. Given integer num, return 3 consecutive integers as sorted array that sum to num. If num cannot be expressed, sum of 3 consecutive integers return an empty array. Okay, shit, what I'm thinking about. So I have to just n plus n plus 1 x plus 1 plus x plus 2 should be equals to num. So 3x equals to num minus 3, x equals to num minus 3 by 3. Okay, n dash define x equal to if n less than 3 return 0. Okay, should it be shit here, someone is calling me. Okay, so you're back now. Okay, so there are three that sum to num. Now can be sum of three consecutive integer, return an empty array. Okay, so num minus 3, and they must not be positive. Okay, so vector of answer, vector of answer. Okay, so if n minus 3 percentage 3 not equals to 0, answer x v, return answer dot pushback num x equal to num n minus 3 by 3, answer dot pushback x, answer dot pushback x plus 1, answer dot pushback x plus 2. I think that's it. Pretty easy problem. 10, 11, 12 for 4, and this would be 4, that should be null. Cool. Let's now move to problem C. Here you are given an integer final sum, split it into a maximum number of unique positive even integers. For example, final sum of the following splits are valid. Unique positive unit sum at final sum 2 plus 10, 2 plus 4 plus 6, 2 plus 10, 2 plus 4 plus 6, 4 plus 7. Maximum number of integers with the final sum cannot be into 2 plus 2 plus 4 plus all the numbers should be unique. Okay, so as all the numbers should be unique. Got it. An empty list. Okay. Unique positive even integers. Okay. So no positive split will exist if the number is odd. Okay, answer final. Okay, so cool. So if okay, let's just name it n. If okay, if n and 1, then answer. Otherwise what I should do is that okay, so the numbers must be, else we can always represent it as the sum of 2 plus 4 plus 6 plus 8 plus 10. We will go on like this, and the last remainder will be added to this, and some destination 10 to the power 10. Okay, so okay, so 2 plus 4 plus 6. Okay, the current equal to 2 unique positive even numbers. Okay, cool. If current equals to 2, the current while n less than current, while current less than n, current n minus equal to current, answer dot pushback current, cool, n minus equal to current, answer current plus equal to 2. Cool, n is decreased by current, and because that sum has already been gotten. Okay, now if n answer dot back plus equal to n, return answer. I think that's it. Compilation error, pushback. Okay, pushback, again pushback, answer dot back. Why is not wrong? Okay, something like this, I think. 2 10. Okay, 2 firstly 2 while current less than equals to n, I think. 2 4 6, cool. First let's check for 28. Let's check. 2 4 6 16. 2 4 6 16. 2 4 6 16. I think that's okay, because 2 4 6, after 2 4 6 12, after 2 4 6 10, 2 4 6 8, 2 4 6 8, 40 goes some, then 6 12 20. Then I think this is okay. I think set submit my code here. Cool, accepted. Cool. You are given two zero indexed arrays, nums1 and nums2 of length n, both of which are, you are given two count good in array. Okay, you are given two zero indexed arrays, nums1 and nums2 of length n, both of which are permutations of 0 1 n. Okay, a good table is a set of three distributions which are presented in increasing order by position both in nums1 and num2. In other words, if we consider position 1v as the index of the value v in nums, positive v as the index value v in nums2, then a good table will be xyz position. Okay, got it. Return the total number of good tables. Okay, sounds interesting problem. This one is a pretty good interesting problem. This one is interesting problem. Long count define bb pushback. Okay, when equals to is okay. Okay, but for a good table is representation integer can be presented, which are represented in increasing order both in nums1 and nums2. Okay, like, okay, so let's 201 201, position of 201 013 013. Cool. Okay. So if we can fix the middle element, like the number of elements towards the left, so if we can fix the middle element, how to solve this problem? So if we can fix the middle element, the number of elements towards the left. Okay. This my current rank 341. That's bad. That is present in both in nums and nums and if the if concentration then applicable will be satisfied as that position 1x less than position 1y and position 2x less than position 2y less than position 2z. Okay, so let's consider 1. Okay, so the elements present towards the up till this index, how many elements are the same? Like this. So up till this one index only 0. Okay. So how can I solve this problem? Only 2 people have solved this problem. Lot of ice. Return the total number of good triplets. Okay, so 20130123. So let's think in this direction. Let's say we know we have fixed the position of a certain element. Or we can think about something like this. Can think about something like this, like 40132 and 41. No, this one is a bad example. 2013 0123. So let's say fix the position of 0 here. Okay, so let's say we iterate on the leftmost guy. Cool. Then the number of elements which are present. Okay, so should we iterate on the leftmost guy or the middle guy or the rightmost guy? Which one would be much more beneficial to think upon it? If we iterate upon the leftmost guy or the middle guy or the rightmost guy, to think in this direction. Okay, so if we iterate on the leftmost guy, we have to find the number of elements beside this position. Okay, so let's say we fix the position of the middle element, like 2013 and 0123. Let's say fix the position of 1 here. So the number of elements which appear in this whole thing, the number of elements which appear in this whole thing would be counted as my answer. Cool. Okay, so now since this is a permutation only, so this one is an important fact to consider here. Since this is a permutation, how can I do this? let's say 17 accepted submissions and 40 unaccepted submissions. Let's stop this and check with in construction. Since this is a permutation type thing, you can think in this direction, like say 1 is fixed. Okay, so each element has some position associated with it. So if I fix the position of the middle element, so can we answer this question like how many elements? Okay, so if we keep an indices of all the elements, then we have to find how many elements have their indices both to the left of this index. So from this we can find the number of elements which have the indices to the left of this element will be something like say x. Let's say 3 to 1, we have the indices to the left of this index. Okay, now among these, how many elements which have the indices to the left of this element also? How can I try this thing? So among these elements, how many of them have their indices? Okay, so if we sort them like this thing, can do something like this, like we can fix the position of the middle element here, and let's say another position of the middle element here. Good. The first problems are very easy and the third ones are a little bit difficult. So how many elements have both their indices present towards the left of it? Okay. Okay, so let's take an example. Let's say 0, 1, 2, 3. Okay. So for this element, these many elements have their positions to the left of this. Okay, so let's say we iterate over these elements 2, 0, 1, 3. 2, 0, 1, 3, 0, 1, 2, 3. Okay, so for this one, we have to calculate how many elements among 0 to are present in 0 also, are present in here also. Okay, so how can we calculate this thing? Some graph 0, 0, 2, 2, 3, 3. Graph. Okay, so there will be some elements. So okay, if we sort the elements firstly by their increasing order and then by their can we do some kind of a binary search here? Like 2, 0, 2, 0. So 2 is placed first here, 2, 0. So among these elements, they should be sorted in the and the 0 to order here. So can I give a priority queue, and then inside this priority queue I have to find the position. How to solve this problem? Only one good reply. Okay. So there is 2013 and 0123. So the position of 1, let's fix the position of 1 here. Now I'm only 02. Okay, so is it possible to find how many of the elements have them on opposite sides? Like 2 can be find out. How can this be found? Like the sum. Okay. So can this be find out by the sum of the two elements? Nope. Okay. So for a particular position, okay, so let's not fix the middle element, let's fix the position of the leftmost or the rightmost element. So basically we have to find the number of elements that occur 1313 that occur as a subsequence in both A and B. How can this be found out? Okay, this thing can be found out easily, I think. Getting much ideas here. So, okay, so so if we fix the position of the leftmost element, okay, so for every element can we find the closest neighbor which is present to the right of it. For 1 it can be 3, for 2 it can be 3, for 1 it can be 2. So the chain is like 1, 2, 3. Okay, so 0, 1, 2, 3. 0, 1, 2, 3, 2, 0, 1, 3. Okay. So you have to basically find the number of elements 20130123 would be more beneficial. I think fixing of middle element is much more beneficial. Let's try to think on that thing only. So if we fix this position like 2 0 1 3 0 1 2 3, we fix the position of 0, then the total number of triplets will be how many occur in left in this and right in this. How can I find this? Okay, so let's say for every element we store these indices. For 0 we store 1 comma 0. For 1 we store 2 comma 1. 0 1 2 3. For 0 we store 1 comma 0. For 1 we store 2 comma 1. For 2 we store 0 comma 2. For 3 we store 3 comma 3. And let's sort them by the increasing order of their right values. No, the increasing order of their a values. So firstly 0 comma 2, then 1 comma 0, then 2 comma 1, then 3 comma 3. Okay, cool. So let's look at this index. We have to find the number of elements which are to the left of this, number of elements less than 0 in this position. Number of elements less than 0 in this position. Default for 1 comma 0, 1 comma 0 number of elements. There is none. For 2 comma 1 for this position, the number of elements have been positioned less than 1. Okay, in this particular thing. So we can keep these things in sorted order, right? We can keep these things in sorted order, right? We can do we can keep a set, like in the set there will be 0 2, and if we find like this, there will be only one element. Okay, so you can keep a set of these elements. I think I am close to that page. So you can keep a set of these elements, and we have to after here just find the number of elements which are less than 1 in this side. So we can do this using a simple set dot lower bound, st dot lower bound, st dot upper bound 1, and this thing will be found. Okay, got it. And in the similar manner, we can find for every element the number of elements which are greater than this thing is in the right part, and then just combine these two parts. I think I am done with the approach part here. So let's try to code this up. First define pi pair of int comma int. Let's define fi first. Let's define sc second. For l I equal to 0, I less than n comma I plus plus. Okay, so like this. Factor of l cos a of n cos b of n. For l I equal to 0, I less than n comma plus plus. Cos a of I equals to I. Cos b of I equals to I. For l equal to 0, I plus plus plus. Let's keep another vector of var c of pushback pos b, b dot pushback pos ai, pos ai, pos bi. Okay, now I should sort them in the increasing order. Sort a dot sort v dot begin comma v dot end. Now what I should do is that firstly I will run a loop from the left part, the ref of n comma south of n for I equals to 1, I less than I plus 1 less than n comma I plus plus answer equal to 0, answer plus equal to ref of ref of I cool into south of I, return answer. Okay, and now I have to calculate this ref thing. For that I will keep a set. Multi-set is not required for left I equal to. Okay, so or a multi-set is required here. Like how can I find the number of elements? Okay, like what is this thing called? Order statistics thing would have been much helpful here, but we can use segment tree of without this, like this, like we can use segment tree here. Okay, so you can just copy the code of segment tree from my template here. We can use a segment tree here. Seg tree or order statistics would have been helpful here, but I have to find that, and that would be pretty much difficult for me. Control Z. Seg tree. So okay, this is allowed here. So construct seg tree here. Okay, control Z. So I need it on the ones. Yep. So construct seg tree here. This should be sound like value. So firstly I have to consider two segment trees here. One for the right part and seg tree sg1 comma sg2 of, and the size of both of them should be n only. sg2 comma n, sg1 this should seg tree should receive Indian integer control Z, n like while size less than n, size into equal to 2, sum dot resize 2 into size 0, build a sum of. Okay, so this build thing is not required since we will just do, we will not build anything there. And just update and query here. Cool. Update 0 comma 0 comma index comma val sum of x equal to val, return sum of x equal to sum of 2 into x plus 1 plus sum of 2 into x plus 2. That's right. Now return 0. This should return sum of x. This should return calculate of this part plus calculate of this part. And finally return answer here. Okay, got it. So segment tree 1, segment tree 2. Okay. Okay. So now for the I equal to 0, I less than n comma plus plus. Okay, now derive of I current equal to derive of I sum of I. So first current derive of I equals to sg dot cal of I dot AC. Okay, so this should be like 0 comma v of I dot AC. I think that's right. Yep, 0 comma v of I dot AC. Okay, so if L equal to R, if L greater than equal to R, this is equal to 0 from here. Instead of calculate 0 comma v of I dot AC, that means the number of elements which are present to the okay, yes. Instead of calculate 0 comma v of SC and SG dot update 0 comma 1, I think. Instead of v of I dot SC comma 1, like this element is present at this position, and let's calculate this sum. Okay, SG1, this should be SG1 not calculate. For L I equal to 0 and this thing I equals to n minus 1, I greater than equal to 0 comma I minus. Okay, sum of I equal to SG2 dot calc v of I dot SC plus 1, number of elements represented with the right of this, plus 1 and comma n minus 1 SG2 dot calc v of I dot SC comma 1. Cool. I think this is it. Maybe comparison will be complete. 0 as expected, not a this first debug our v here. Okay, so v of I dot v of I dot SC slash 1 0. So why this is 1 0 0 to this? Okay, I have not sorted it right. So why is it first 1 0, right? Okay, got it. Okay, so 0 2 1 0 2 1 3 3. Cool. Now right, play for 5 for that I will 0 plus plus C out ref of I, C out slash n, ref of I for 2 for because for 0 2 there are no elements have been updated, so this is 0. For 1 0 inside 0 there is no elements, but for 1 here there is only 0, and for 3 3 there are 3 elements, 1 0 and 2. Right, good. I think the sum of I part is wrong here. For I equal to n, I equal to 0 less than 1 plus plus. I think I miscalculated the sum of I part. See out sum of I. Okay, this should be n. This should be n. First let's do it and then check. No, still wrong. Okay. See out sum of I. See out slash n. Plus 1. Okay, so sum of I part is 0 only. Okay, I have to increase 0 only. Control X, Control V. Okay, is not y cout slash. Yeah, what is Leetcode? You are very bad. 1, this is the incorrect answer. 1 2 for this cell, for this 2, for this should be 0, for 1 this should be 1. Cool. For 0 there, this should be 2. For 2 this should be 1. Right, this is incorrect answer right now. I think this is, my code is correct here. Then this code is correct here. Let's remove all of these things and run my code again. 40132 41023. Let's pray to God that it gives the right answer. 40132 41023. 4 cool. Submit my code. Cool, accepted. Cool. That's great. Let's see my rank right now. Cool. So we are done with the contest here. Problem 4 was really a good problem for me, but the first problems were little bit very easy, but that's how it ended. Let's see my rank right now. 145 rank. Cool. So I can, since I don't have any penalties here, I can surely write under 150 rank here. So I can surely post in my YouTube screencast rank under 150. How many guys have solved problem 4th year? A lot of guys have solved problem 4th year. No, not a lot of guys. 14. How come 14? Okay, this is not a problem. So 145. Cool. I don't have any penalties here, so that's great. So that's it for this video, guys. I am getting a very cool rank here. So thanks for watching this video. Bye.